Welcome to the introductory video for getting started with the Open Perimeter Interface. So the OPI interface consists of three parts. There's the R script that you write, which will make use of the R package. There's a thing called the OPI server, and finally there's the perimeter itself. So you write some R code that gets translated into messages that get sent to this server. The server in turn talks to the perimeter and presents stimuli, gathers responses, that comes back. The server interprets those from the machine, sends back the results to the package, and finally you get your results into your R code. So this three-part, we've got the client, we've got the server, and we've got the perimeter. Seems a bit complicated, but the reason for using it is that it gives this part here, the server, as a control or a key to the companies that own the perimeters. If they want you to use the OPI, they'll enable this. If they don't want you to use the OPI, they won't enable this. And so that's good for legal reasons and other commercial reasons. So companies have control over who can use the OPI and who can't. It also allows a standard set of functions to be implemented here, and the translation to different machines happens here. A little note here, if you're a hacker, you can send the right messages to this server using any programming language at all. You don't have to use R. It's just easier if you use R. So how do we go about getting started? First of all, we need this server thing. Each machine has its own server in different ways. So the Octopus 900 has a Java program that runs on the Windows machine connected to the 0900 and talks to iSuite. The Compass, the server, is built into the machine, but has to be activated. The Koa, like the Octopus, has a separate program that runs on the Windows machine connected to the AP700. And the final two we don't need to worry about too much. So contact the company to get your server, and I can put you in touch with the right person at the company. It's a little bit fiddly to set these servers up, but once it's done, you don't need to do it again. The next step, install the R package. Hopefully you all know how to do that. Then the final step is to actually do a run. So here's some R code here that will call the OPI. So make sure that the OPI package is loaded, so using require or whatever. First of all, we choose the OPI implementation we want to use. In this case, we've chosen a simulation. We construct our stimuli, which is a list of class, in this case, static stimulus, although there's other types. Then we initialize the machine, giving it any parameters it might need. In this case, we're using the Henson simulation, and so we have to tell it some information about the frequency of sine curves that we're using in the simulation. And then finally, we present the stimulus and print the output. And so this will wait until the machine has presented the stimuli and sent back the result. The result we get is a list, something like this. It always contains these three components: an error, null is good, means everything worked fine, seen, true or false. And finally, the response time. In simulation, there's no response time. So if that all works, fantastic. Next, we can run it for real just by changing this line here, and we'll have to also add a few parameters in our OPI initialize. So for example, for the Octopus 900, we change it here. Don't have to make any changes here. We'd have to add a few things here. We don't have to add all of these, but I've put them there for completeness. And away we go. So there's a couple of things to note. First of all, for any of the functions beginning with OPI, so OPI present, OPI initialize, there's also OPI set background and OPI query device. All of the parameters to those functions have to have names. So here I've got stim equals. Here I've got equals, I equals, big wheel equals, etc. So all of these parameters have to be named. For more help and information on the type of functions you can use and what else is in the OPI package, see our next video.